Okay, let us answer this question that was just recently sent to my email. So we have been given that a plus b plus c equals to 0, and we should show that this equals to 2. Okay, so how are you going to begin? So you see that here we are having a squared plus b squared. So we need a squared. In other words, we can just square this our equation that I can call equation 1. So if we square it, you simply get a plus b plus c, all that squared have to be equal to the right hand side squared. What you do on the left, you do on the right as well. So this will be equals to, and the right hand side squared will just be 0. 0 squared is still 0. And the left hand side squared simply means it's multiplied by itself. That's the meaning of squared. So we multiply this by itself, and we are going to open this bracket. And when you are opening this type of bracket, you have to take a and you multiply by everything here, b you multiply by everything here, c multiply by everything. So let us go ahead and do it. So we have a into a plus b plus c plus b into a plus b plus c plus c into a plus b plus c, and all of that is equals to 0. So let me go ahead and cover this plus here. Okay, this is, I've taken this a here, I've multiplied by all of everything in this bracket. I've taken this b, I've multiplied by everything in that bracket. I've taken this c and I've multiplied by everything in that bracket. This is it here. These are the brackets. This bracket here. Okay, now let us go ahead and open the bracket gently. So if you open this one, you'll be having a multiplied by a, by having a squared, then plus ab plus ac, correct, plus, but b times this, we have ab, or b is the same thing, plus b squared plus bc, that is multiply everything inside, plus then c times a, we are having ac plus, I just like to write in alphabetical order, c times b is bc plus c times c squared, all that equals 0. I can go ahead and join like terms, that is the ones with higher degrees. So I'll start by combining a squared plus b squared plus c squared. If you are not seeing it, this is the a squared, this is the b squared, and this is the c squared, and all of them, they are having positive signs in front of them. That's why I'm having this positive sign. Okay, now let us go ahead and combine the next. This is ab. So we're having, how many ab's are there? 2. So we're having 2 ab plus. So now by, if you have used it not to confuse, you can use your pencil. So AC again, so we have 2 AC plus 2 AC, and we have BC. We also have plus 2 BC, and you should be solving and looking at your proof on b squared minus AC. Okay, now equals 0. Okay, now we are now having a squared plus b squared plus c squared plus 2ab plus 2a plus 2, I can just put bc plus 2ac, something like that. The c should be at the end, the b should be closer. So we now can now factor out 2 here, since we do the what we need there is no 2 to already have our 2. So we have a squared plus b squared plus c squared plus 2 into ab plus bc plus ac. Oops, there is equals to 0 here, equals 0. Okay, now if you are having like this, you see that this AC here is already in our proof, and we are not having C again, we are just having B without C here, and we are having AC. We have seen the 2 and we have seen our AC. So what we will do, we'll look for a way to remove this A and this C here. But we know that A plus B plus C equals 0. We can make A plus C equals to negative B. So we can go ahead and manipulate this to have it. So we can say a squared plus b squared plus c squared plus 2 into, here I can factor out b into a plus c plus ac equals 0. So we are having like that. So this my a plus c here, let me make it yellow. So this one here, that I've just factored out this b here and this b, remaining with a plus c. So this a plus c, I can replace it with this negative b. This is it here from equation 1 that we have been given. So we can now see that a squared plus b squared plus c squared plus 2 into b into negative b plus AC equals 0. Correct. And now if we go ahead and simply we now have a squared plus b squared plus c squared plus 2 into negative b times negative b will be negative b squared plus AC all that equals 0. The 0 is not coming out. And now we can go ahead, and since we are having on the right hand side we are having a plus b and 2, so I can take this other term that contains 2 to the right hand side. So we are having a squared plus b squared plus c squared equals to negative 2 into negative b squared plus AC. Correct. So I can go ahead and open the bracket on the right hand side. So we are having a squared plus b squared plus c squared equals negative 2 times all of this. Will be having, we can multiply this by this and this by this. So now we are having negative 2 into negative b squared minus 2AC. Multiply the negative 2 by AC, which is positive. And we now simply get this here, we get 2b squared, 2 times that minus 2AC. So we can go ahead and factor out 2 here, 2 into b squared minus AC. And on the left hand side, we are having b squared plus c squared. We can go ahead and divide everything by b squared minus AC. And divide also the left hand side by b squared minus AC. And on this side, you see that this one now, will just go with this. I simply be having a squared plus b squared plus c squared all on b squared minus AC equals 2 as required to show. We procure 80. And that is all. So this is how you do it. So you just what we have done in summary is that we have just squared both of the equation to get our a squared plus b squared plus c squared, and we just simply factor out everything. Since we are not having any 2, we found 2. I've just factored out everything, and we are not having any b a in this equation or bc. We are only having AC, so I've gone and factor out this. I've tried to eliminate this AC by factoring out b and substituting that AC, that a plus a to be negative b, and then we just had our proof. Thanks for watching, and make sure you like and subscribe to the YouTube channel. Have a great day.